So this describes a Deadman trigger at nauseum here, more than you ever want to know about a Deadman trigger. Why, page after page of Deadman. These are the things I've already talked about. Oh, the trigger lock. You can lock it manually, but let's say you set the instrument down and you go to get some more samples or whatever you're doing, it will lock itself in 5 minutes, okay? So, and it's just showing you, we'll go through this when we're running the instrument, but it just shows you how to unlock a trigger. And this is describing the proximity sensor, 1 to 2 seconds it cuts out. And then the test stand, I mean, that's, you know, there are no x-rays are escaping at all. So it's great for doing soils and other small particles, or small parts. I've got some customers that, even though they're doing metal, they're manufacturing small parts, you know, little fittings and things like that. They have instruments they never take out of the test stand. It's in there 100% of the time. And this is just a directory that you can get and find out what your own state regulations entail, but we can get you that kind of information as well. But basically the bottom line is common sense. Don't play around with it. Realize that, you know, the radiation is coming out, and pay attention to all the lights. Okay? Any questions? Okay. If you've got the tube and it knocks out either a K or L shell electron, the two most inner shells, okay? But why one or the other? Well, it's all depending on the binding energy of that electron shell to the nucleus, okay? For instance, so remember I mentioned it's a 40 keV tube right at the window, it's less than that. Okay, so let's take lead, that's easy. And a lot of you are going to deal with lead. We use the L shell of lead. And the reason is it takes about 23 keV of energy to dislodge an L shell, a K shell. Well, we don't have 88 keV, so we can't dislodge, we don't have enough power to dislodge the K shell, but we do the L shell. Okay? Other elements, we can do the K shell, copper, nickel, molybdenum, things like that. We have enough power to dislodge the K shell. All right, so that's what we would use. And we do the other ones as well, but the thing is, the energies coming back are so weak they don't get to the detector, just not measurable, or they're down in visible light or something like, or UV light, I should say. So we're using either the K or L depending on the element. So when we knock one off, the other electrons get excited, go, oh, there's an opening in a better shell. You want to get as close to the nucleus as you can. If we thought like electrons, that's what we would want to do. We'd keep moving into